So 8-3 day two. What we did the other day was just proving that a quadrilateral was a parallelogram. So just kind of the next extension of that. If you kind of remember the flow chart that we did where we would have a parallelogram and then there's a bunch of different types of parallelograms. One of them is a rectangle. So if we understand how the flow chart works, if we're going to have a rectangle, first and foremost, it's going to have to be a parallelogram. So a parallelogram is your opposite sides are parallel. So this side and this side would need to be parallel. And then this side would have to be parallel to that side. Those are opposite sides parallel. And then the opposite sides need to be congruent. So if this was 10, then this would need to be 10. Say this was 8, this would need to be 8. If it satisfies both of those conditions, then we could conclude that we're dealing with a parallelogram. For a rectangle to exist, not only does it have to be a parallelogram, so it has to satisfy the same exact requirements we just wrote down up here at the top, but it also have to have 90-degree angles. So these have to be 90 degrees. And then what we did with that to prove something or two lines intersected to form a 90-degree angle, those were when we talked about slopes, and they needed to be opposite reciprocals of each other. So similar to what we did last week, the last lesson, proving a parallelogram, we'll do some similar stuff here. We're just going to add the third element, which is we need 90-degree angles. So for number one, if we look at A, B, C, D, to the right on our graph, we want to determine if opposite sides are parallel. So if we look at AB, so here, and then DC, which is here, we talked a little bit if it's horizontal or vertical lines, we don't have to really do a whole lot of work. We can use those as just kind of statement of facts. So in terms of opposite sides are parallel, side AB is definitely parallel to side CD because they are horizontal lines. And it's just known that if they're both horizontal, they're going to be parallel. We can also say that AD is parallel to BC, and same reason because those now are vertical. And like horizontal, if we have vertical lines, it's known then that they are parallel to each other. Opposite sides are congruent. So let's do AB and BC first. They would have to have the same lengths. Okay. Actually, correction, AB and CD are the opposite sides. So AB and CD have to have the same length. So if we look at A is starting at a -8 along the x-axis, and we have to move over to here, to here, to here, to here, to here. That ends up at this tick mark, which is 2. So understand each tick mark is 2 units. We went from a -8 to a +2. So that would give us a length of 10. And then just look to see if D to C does the same thing. D is also starting down here to -8. We go 1, 2, 3, 4, 5 units to the right. 5 units to the right when each one of them is 2 is another 10. So again, started at -8, finish at the -2. So this is 10. So we can prove that. A to D, and then C to B better also be the same, and we can kind of look at that and make this conclusion as well. Let me do this in red. So here, this is really at the 9 value, and then we go up to the middle. So notice how this is in the middle. So we go up to another middle, up to another middle. So we went up twice, middle to middle, and since each tick mark is 2, this has a length of 4. If we do the same thing here, from this tick mark to this tick mark to this tick mark, that's 2 steps. Each step is 2 units. So this is also 4. So if we ask, are each side congruent? They are. We have 10 on top, 10 on the bottom, 4 on the left, 4 on the right. So the last thing is 90-degree angles. And really no work when we have horizontal and vertical lines. We would say yes. And we can just allude to that because AB and CD are horizontal, and because AD and BC are vertical, and it is known vertical. vertical, let me try to spell that again. It is known that horizontal and vertical lines are perpendicular to each other. So it satisfies everything. Opposite sides are parallel, opposite sides are congruent, and our sides are forming 90-degree angles because this horizontal line and this vertical line, they're intersecting and forming a 90-degree angle. They're 90 degrees here, 90 degrees there, 90 degrees right there. Okay, so that's our process. That's what we want to go through to actually prove if a quadrilateral is a rectangle or not. Okay, so the next one, you can see it's shifted a little bit, it's rotated. That'll make us think a little bit more and actually have to do a little bit more work, but nothing too crazy. So if we look, it says, is the quadrilateral EFGH a rectangle? So if we look at opposite sides, so let's do EH and FG. So if I go EH and FG, let's find their slopes. Okay, so to figure out the slope of HE, notice how you're in the middle here. So I'm just going to go up in the middle. So I'm going to go up 1, 2, 3, 4, and then this would be a half. Okay, so think about what that would now mean if we're actually going up. Every step is 2. So I'm really going from here. That's 2, 4, 6, 8, and then to half would be a 9. So when we create a little right triangle here, this is up 9, and then we're in the middle. So I'd go here. That's a two steps because every tick mark is 2, 4, 6, and then a 7. So this is 7 units long. So the slope of H to E is 9/7. If we go to F and G, so let's start here. We have to go up from this point to this point. So we go up in the middle. So that's 2, 4, 6, 8. And then we only want to get to this point, so we have to go up just this half. So that's 2, 4, 6, 8. This would be 9. So we have 9 here. And then half is 2. In the middle of here is 2. In the middle of here is 2. And then we get here. So that's 1, 2, 3, 4 and a half. I'm sorry, 1, 2, 3 and a half, which each one of them being 2. So 3.5 times 2 is a 7. The slope of this one is also 9/7. So that's a good thing. Keep that in mind also. Up 9, right 7. For when we talk about these opposite sides being congruent. So let's actually kind of do that one now. So if we did EH, we still have a little work to do with the other sides, but let's do EH now. Think about if we set up a Pythagorean theorem for this. 9 squared plus 7 squared is equal to, here is the C that we'd be looking for here. That's our hypotenuse. And then look at FG. Or is it FG? Yeah. So that's this side here. Wouldn't we get the exact same thing? We would have gone up 9, right 7. So we'd set up another Pythagorean theorem for that. 9 squared plus 7 squared equaled C squared. So if these are identical, wouldn't it make sense then? Wouldn't it be logical that whatever we solve this equation for C, so this would be 81 plus 49 equals C squared. Give us 130. Take the square root of 130, and that should be 11.4. We would also be able to conclude then this is going to give us the exact same steps. So these are each 11.4. So we know EH and FG. So I'll shade these in black. They were parallel, and they're going to have the same lengths. So the second part of this is now showing, since we know these are good, clear this off a little bit, is the other two opposite sides. So now we want to do, so let me draw a little line in here and then here, EF and HG. EF first. I'm going to go in this direction. So we go up 1 tick mark, but no, that's 2, and then 4, and then 6. So from F to get up to E, we're going to go up 6. And then I would go left 2, 4, 6, 8. So 6 over a negative 8. If we go to HG, we try the same thing. We're in the middle of this one. So if I go the middle of this one, that's actually 2 steps up, 4 steps up, 6 steps up, get us even with H, so up 6. And then to the middle here is left 2, left 4, left 6, and to the middle here would be left 8. So notice how we get the exact same slope for those. So we know the opposite sides are parallel. And then let's actually now draw our little right triangles in. We said this was 6. We said this was 8. Same here. We went up 6. And then we went right 8. That would only then make sense that these would have to be the same. If we set up our little Pythagorean theorem problems, each one of these is a 6 squared plus an 8 squared equals your C squared. Add those up. It should be 100. And take the square root of both sides. Each one of these sides, this is a 10. That is a 10. Therefore, we can say that EF and HG both have a length of 10. So we know it's a parallelogram. These first 2 requirements are what we need to know that it's a parallelogram. Not a guarantee that we have 90-degree angles. Their slopes need to be opposite reciprocals of each other. So our slopes, so E, H, and F, G had a slope of 9 over 7. And then E, F, and H, G had a slope of a negative, let's reduce, so I'm just going to reduce this slope here to a negative 3 over 4. Either way, even if we don't reduce this, just so we don't worry about if it has to be reduced or not to compare, if we look at these 2 slopes, if this is the slope of one of them, one set of our lines, then the perpendicular slope to this, so here, if you remember our perpendicular symbol, would have to be the opposite reciprocal. So we would need to flip those. So put 7 on top, 9 on the bottom, and then a negative sign since our original was a positive. So this one and this one are now opposite reciprocals. That's not what the slope of the second one is. So in terms of do we have 90-degree angles, the answer to this is no. So we would then be able to say, even though it was a parallelogram, this is not, even though it looks like it was very close, not a rectangle. Okay, so that's why we kind of want to go off this and not just go off our general assumption by looking at them. So with that, that's pretty much all we are looking to do. Same thing we would have done the day before, prove that they're parallel with the same slopes, prove that they are congruent with the same lengths, and then now if they are, determine if all those angles, so where the opposite sides are intersecting the other set of opposite sides, you better have slopes that are opposite reciprocals of each other. All right. Okay, with that, bid you adieu. Have a good day. We'll see you guys in a little bit.